Good morning, ladies and gentlemen, esteemed guests, respected dignitaries, and fellow solar enthusiasts. Welcome to the day 2 of second edition of EPS EXPO 2025. Well, can we start the day with a thunderous round of applause, ladies and gentlemen? Let's create some good energy to start with. Let's do that. Come on. Thank you. Thank you so much. Well, my name is Dr. Azra Khan, and I'm extremely delighted to be your host for this wonderful day ahead. Well, yesterday, we set the stage for an exciting journey into the world of solar energy. And today, we are going to take it to the next level. As we continue our exploration of the solar revolution, we'll be diving deeper into the latest innovations, trends, and opportunities that are shaping the future of our industry. Today's agenda is packed with insightful sessions, keynote speeches, and panel discussions that will give us a closer look at the technologies, policies, and investments that are driving the growth of solar energy. We'll be hearing from the industry leaders, experts, and innovators who are pushing the boundaries of what's possible with solar power. Whether you are a seasoned professional, an entrepreneur, or simply someone passionate about renewable energy, today's session will provide valuable insights and opportunities to connect with like-minded individuals. So let's get started and make the most of this incredible event. Ladies and gentlemen, we have a keynote speaker with us who will be discussing about the International Solar Alliance. I would like to welcome Dr. Sanjay Kumar Pradhan, MA, MPhil, PhD, JNU, New Delhi, Head of the Department of International Relations, Associate Professor of International Relations, School of Liberal Studies, Pandit Deen Dayal Energy University. So ladies and gentlemen, with a huge round of applause, let's welcome Dr. Sanjay Kumar Pradhan ji.
फोन तुम्हारे पास है भाई मेरे पास नहीं उसी है बाकी मैं तो संदेश मिला तो नेट
Good morning, ladies and gentlemen. It is a great pleasure and honor for me to be present before you and to express my viewpoints on International Solar Alliance. So, this is basically core to my subject area, as I belong to professor in the Department of International Relations, and all of my books, articles, and all the activities are surrounded with that of energy security and energy geopolitics. Practically, I was working on that of oil and natural gas sector, but gradually I have shown my keen interest and inclination in the areas of International Solar Alliance and other aspects of renewable energy. So, I would start with that of the mission and vision of our Honorable Prime Minister Narendra Modi ji, because since 2014-15, we have seen much of progress in the renewable sector, and very recently to that of the Panchamrit and focus on critical mineral resources, which are used for the renewable sector. And this International Solar Alliance is largely the brainchild of our Prime Minister and the former France President Francois Hollande on the sideline of COP21 in the Paris conference. And starting from that of the two leadership, now its membership has increased to 107 member countries and that of the 17 dignitaries. And the process is ongoing. Initially, the organization was only for the tropical countries, but later on it has been expanded to all countries who are the members of the United Nations and who adhere to the charter and who have clean interests for this solar sector. They can become they can apply for membership in this organization. And its slogan, later on its slogan came one world, one issue, one sun, one energy, and one world and one grid. So issue slogan that later party to develop. And some of the, here I would like to say that some of the progress it has made in the solar sector through this ISA. So the list is lengthy one. The initiative is it is a starting process. And because we see it is established in 2015 and the formal, it will become a formal one in 2016. So 16 to 2025, it is about just 10 years that many initiatives it has taken. So some of the steps that with regard to that of it has to establishing the mobilizing the fund or establishing a corpus fund and installation of solar rooftop and that of this water supply and many more initiatives they have taken. And basically these countries are in Africa or that of Asia Pacific region. So, and now the countries, some of the, as the progress is going on and the countries, the focus, the primary focus now they are looking for to least developed countries and that of the other countries which are not doing much on the economic front. So that primarily they are now focusing on these countries and not primarily we can say, but prime focus we can say. And gradually the process is evolving. And if you see that of the important aspect, one of the CPS I am telling you, country partnership strategy, CPS, it is, if we see that three neighboring countries, that is Nepal, Bhutan, then that of Bangladesh and Niger. But fact is that as there is political uncertainties on turmoil in the countries like Bangladesh, then that of Nepal. Of course, Bhutan it is stable government now. And if you go to the Nigeria, so there is also political disturbances. So here in this context, it is some doubts how this country partnership strategy, which is very specific, bilateral approach will be get materialized. That is some sort of question. Yes. So some of the two important issues I would like to mention here. As you know that it is India's initiative and its headquarters is in Gwalior, Gurugram, and it has not yet structurally and functionally, it has not set its tune because the secretariat that we have, that is also not permanent, and the structure, mechanism, staff, that is inadequate. And if you see the functions, the membership is voluntary and there is no monitoring mechanism and no enforcement mechanism and no punitive actions if the countries are not taking to the agreement clauses. So these are some of the issues we need to be taken care of because it is not like that of the UN structure or that of the COP type of arrangements. So it is an issue that we should take care of how the policies, programs, decisions will be very effective and purposeful. And another problem that I would like to mention here, many projects, pilot projects or skill development initiatives, startups, it has made progress. But it is not up to the mark as it is expected. And India is one of the major contributor in this area, as I have shown you in the corpus fund or that of the fund mobilization, where India has a major contributor to the financial aspects. So some of the suggestions I would like to mention here. As I said, the structural and functional issues that needs to be taken care of. And second is that funding and large amount of money that is required. So where the money will come? So it is an issue because basically the money comes voluntarily from the country. So capital, so it is an issue how it can work. No doubt, ISA has got support from the World Bank. IS is financing through the banner of ISA to popularize the ISA initiatives. But it is not up to mark, as ISA itself has its no strong fund or financial mechanism. And the third point is that it is important. We need to have a collaboration with other renewable energy agencies like IEA and IRENA. It is necessary to have cooperation, assistance, and if required, some financial and technical assistance from IRENA and IEA. Yes, China is not a member. It has neither signed nor ratified the ISA Charter. China is important because China may be a strategic competitor, may be dominating the global supply chain of uranium, lithium, and global critical mineral market. It is largely dominated, maybe in the terms of production, processing, maybe in the terms of critical minerals, maybe in the terms of equipments and instruments which are used for the solar sector. But we need China as a partner or a member of this forum. And the global south perspective, yes, we see, if you see the IRENA or IEA, so basically we see that is largely dominated by the developed countries. But ISA is to bridge the gap between the rich developed countries and the poor or least developing countries. So fact is that as this organization witness membership of both developed and developing countries, as we know, issues will come up, because when we are saying that of renewable sector in the developing countries vis-a-vis the renewable energy requirement in the developed countries, difference is there. When for the developing countries it is equity, and how financing and to what extent availability of the machineries, equipments at an affordable price. So no doubt there is north and south, they have differences. But fact is that this organization is very hopeful to bring the demands and expectations of both sides to a negotiating table, so that a united effort at the global level is possible. Okay, thank you. So anything from question, comment, and query will be most welcome.
Good morning, sir. Dr. Anand Kumar. Is there any review of the proposals, what they earlier did when this consortium was formed? Have they reviewed and are they still working on that to bring it back onto the track?
Yes, fact is that review and that process is not yet done largely. And that is also a key point that whatever the investments or planning or the steps taken, so how much it is has become effective and successful, proper assessment has not yet done. That's why I'm saying that the monitoring mechanism it is lacking.
Okay.
So, I'm Dr. Harsh Sethi. You talked about China being out, but currently, like US with the Trump administration, they are also not focusing on anything renewable. They are talking about drill, baby, drill, which is going back to fossil fuels. How does it affect the ISA policies of, making Earth green and cutting down on carbon emissions? One of the major economies of US and their allies, they are not looking forward to it.
Yes, sir, it is a nice question. And US itself a member of ISA. And contradictorily, they are going in a different direction. But if you see the foreign policy shifting, if you say the Obama period and Biden period, they were they adhered to that of the COP21 and then that of the ISA. But this government making some negative, developing negative rhetoric on that of the climate change. So support is most required, but here yes, I am doubtful because it is the one of the largest polluting country and it has the high technologies. But if without their support, China is important. Likewise, US is important. So it is the US for the better cause of the global community should understand what they should do for the climate change mitigation. Okay, thank you all.
Thank you so much, Dr. Sanjay Kumarji, for this insightful presentations. Well, ladies and gentlemen, can we have a round of applause for this wonderful presentation? And to honor the insightful session and the invaluable contributions by Dr. Sanjay Kumar Pradhanji, would like to felicitate him, for which I would like to invite Mr. Pradeep Kumar, BD Head Industrial Outlook, to please join us here on stage. And I request Dr. Sanjay Kumar Pradhanji to please join us here on stage. Now I request Mr. Pradeep Kumarji to kindly present the memento to Dr. Sanjay Kumar Pradhanji. Come on, everyone, let's have a round of applause. Thank you so much. Now, ladies and gentlemen, up next we have a corporate presentation by Mr. Sarveshwar Deshpande, Enerson Technologies by GeoThings Limited. We'll be discussing about the GeoSpark microinverters, partnered by PowerTrack Group. Let's make a huge round of applause as we welcome Mr. Sarveshwar Deshpande ji. And after this corporate presentation, we have a wonderful session discussing about the energy storage and grid stability, where we'll be discussing about the peak shaving, load shifting, frequency control, learning from pilot projects in India and abroad, open access, ancillary services and tariff mechanisms, role of CERC, SERC in enabling storage participation, solar plus storage, wind plus storage and hybrid power plants, and standards, testing and safety frameworks. So I request you all to kindly be seated, and I request all the exhibitors, all the visitors to kindly join us, because up next we have a wonderful session which will be moderated by Mr. Satish Suri, Managing Director, Green Path Energy. And the speakers, Mr. Shailesh Modiji, Senior Manager R&D ERGA, Mr. Dilip Patel, Founder and CEO, Mantra Enterprises, and Mr. Sanjeev Kumar, Senior General Manager, Torrent Power. And now we have a corporate presentations by Mr. Sarveshwar Deshpande, Enerson Technologies by GeoThings Limited.
So can you start the presentation?
Good morning, everyone. So, Geo has entered into renewable energy market, and they have recently launched their solar micro inverter. So, we'll brief through this presentation. So, GeoThings Limited is our company, which is actually catering all the IoT-based solutions all over India. So we have one-stop solution. We also have Make in India policy, where we are manufacturing all these equipments and designing, developing within India itself under Make in India brand. We also have a collaboration with Google, Microsoft, Qualcomm, other giants for our technology partnerships. Under Enercent, we already have launched our brand GeoSpark, which is a solar micro inverter. Also have launched EV battery chargers under Enercent. So Enercent is our branch which has been formed specifically to cater renewable energy products within India under Make in India also. So let us go through this solar microinverter background briefly. So conventionally, we have two types of microinverters or inverters in solar industry. One is centralized and other one is microinverter. So under centralized, it comes centralized inverters as well as string inverters. And in other branch, we come along with power optimizers, couplers, and third one is microinverter. So with the legacy inverters or the traditional inverter, what basically happens is whenever we want to increase the power, we have to combine all the DC solar panels, and the combined input is given to inverter through coupler or power optimizers. So in that case, what happens is the DC voltage is multiplied, and the DC supply is pulled through the entire surrounding or entire structure. The DC cable or DC supply pulling is very hazardous. It's considered to be very prone to accident because it is very likely to catch fires. So you can see that some high voltage and always alive kind of things are there which are in DC, unlike AC supply. Third is arc fault. So whenever there are bends through pulling the cabling, so there are arc tends to be there, which may prone to be hazardous, unsafe for firefighters, and many industries have now stopped allowing DC cables to be pulled through their infrastructure for installation. So at these points, our micro inverter actually plays a big role. So through conventional cabling, what used to happen is whenever we connect or couple all these panels together and give it to inverter, and suppose 20 panels are connected and couple of panels get some shadow effect or they get some damages, then the performance of entire string becomes very zero, or it can come down to a very negligible. So in that case, our inverter or our thing is very boom kind of thing, because we have separate MPPT for each inverter. So 4 MPPTs are connected. It is called as quad input. Any panel voltage or any panel size can be connected. Combination of sizes can be connected. And if any one panel goes bad, if any problem comes to one panel or shadowing effect comes, then two other panels will perform to the fullest and it will give the best energy efficiency. So this is a graphical representation for the same. So the benefits which we offer through this model is panel level performance monitoring is there. So for that we already have one IoT based devices which is a SIM based device and which captures the data of energy metering from microinverter and also panel level data, and it can be displayed on our portal, which is available through Geo application over mobile phone. Panel partial shading support is also there. Panel mix-up, that is upgraded failure, is also there. Multiple panel orientation support there. Gracious capacity loss fault. So inherent safety is there. As I already mentioned that DC cabling is lowered, so safety concern is taken to the highest priority. Native compliance to rapid shutdown, because it is having inbuilt protection system as well, and IP67 rating is there, so it is fully compatible for outdoor installation. The warranty is of 25 years. Standard warranty comes of 12 years and it can be extended to 25 years. So this is basically some comparison between legacy and microinverter. So string inverter and power inverter or power optimizers are comes in the same category, where in contradictory, microinverter has some added feature. So this is how our microinverter works. So it has 4 MPPT connected, and each MPPT can be connected to one panel. So it can be a combination of panel from 350 watt peak to 680 or 710 watt peak. Any combination can work. So independent MPPT being very efficient of power generation. It also has capability to give power panel level monitoring, and the key feature of this microinverter is it operates on dual mode. So what dual mode means, it can operate in on grid mode as well as when the grid is not there and the battery is not there. Of course it is not having battery, it's not hybrid inverter, but when grid is not there and the sunlight is there, then during that time, based on the sunlight intensity, the power generation can be done, and our minimum load can at least work without any failure. So that is a unique feature, which is dual mode technology, which is patented by us. So Spark is our company, which actually we had a technology partnership, and now we have acquired them for our India operations, and we have started a manufacturing plant in Noida as well. So it is completely Indian, make in India based technology. Even the communication device has a SIM card inside it, and the SIM card is from Jio. The database is also maintained by Jio. So everything, as MNRE has laid down new GR, where they have compared to use local database and local SIM card based technology for security and safety purpose. So we already are compatible with these MNRE's guidelines. So this is basically some graphical representation how on-grid and off-grid works. So on-grid technology, I think everyone of you are available or aware that how it works. So similar way our inverter also works. Where difference is made is when it comes to off-grid. So whenever off-grid comes into picture, in that case we already have designed a specific ACDB device for it, because ours is patented technology and dual mode is not available anywhere in the market. So no one provides ACDB which caters dual mode. So we have developed this specific ACDB, and this is the proven technology. So that ACDB, what it does, that it actually performs two operations. One is ACCL operation and another one is ACT operation. So through ACCL it changes over from grid to solar, and through ACT it isolates the grid from solar, so that no generated power from solar is fed back to grid, which is illegal. So that both things are taken care, and whatever the available sunlight intensity is there, through that the generated power is directly transferred to load. So generally we suggest that 30% of load capacity to be installed in off-grid, just to make sure that there is no tripping issue, because even if we can operate complete load when the light intensity is high or is fullest, then maybe sometimes it may happen that the load may go high and the generation is low. So in that case the inverter will trip. So just to avoid that, it is taken care. So this is a graphical representation of how it works in on-grid and off-grid. This is specific ACDB which is used for off-grid and on-grid dual mode technology. If you want to install it in a single mode, then any available ACDB in the market can be used. It's very easy to install. It can be installed below the panel on the structure, and which will need very few DC cabling. Plus it is IP rated, so no hazard in installing it below the panel. So this is how basically this Cat1 technology work, our device. It can connect up to 6 inverters, and if there is any requirement of higher devices or inverters to be installed in one project, say 15 inverters or 20 inverters, in that case we have a sparkling model which operates on Wi-Fi, and it can connect up to 22 inverters. So these are some examples. We have installed this 80 kilowatt of project in our carport project. This is in RCP, Reliance, Mumbai. So we already have 1.5 megawatt of project installed over there, which we are converting it into this particular micro inverter. So these are few combinations for 72 watt peak and 72 kilowatt kind of project. This is the portal Sanjini, which is our design and developed portal, which extracts and captures the data from a micro inverter, and with all the computations it provides the figures of power consumption and reports, daily reports, monthly reports kind of facilities on our portal as well as on mobile. So Sanjini is available for mobile as well. So these are some glimpses how it looks on mobile as well as on the telematics portal. Thank you very much.
Do we have any questions?
Yes, sir.
You said that for anti-islanding, it's a feature taken care by ACDB.
Sorry?
The
Anti-aliasing, yes. Okay.
anti-islanding, that
Yes.
feature taken care by your ACDB, not
Yes.
by your
Yes.
smart expert. So that ACDB is tested for the anti-islanding requirements and reconnection of the.
Yes, yes, it is tested. So just to brief you, this microinverter, we had done a technology partnership with Spark for our internal usage, because it is basically for towering project. We have almost 5 million plus towers across India, and some locations does not provide stable grid. So to cater that requirement, we started searching for this off-grid microinverter, which can support or which can provide power directly through solar paneling. So we came across this Spark ka product, and when we learned and when we started digging into the technology, we came to know that it doesn't have any specific ACDB which supports this category in India. Then we developed this ACDB, and when we tested it in our project internally, in-house projects for our carport, our towering as well, and when we proved it to ourselves last year, then we started, getting into this in commercial mode. Yeah. So it is
Thank you.
proven one. So that's why we provide SLD. So we do not provide any product directly. So we provide SLD for that.
Good afternoon, sir.
Yes, sir.
Sir, how affordable it is for residential users? Like,
Yes, it is approved under MNRE also in PM Surya Ghar Yojana. So you can get subsidy, one thing. Second thing is the generation of this micro inverter is greater or higher as compared to other inverters or other products. This way you can get earlier or sooner REI can be there. Third way is the off-grid technology which it offers. Whatever is generation there, that is completely boon, or it is completely kind of we can say additional generation, which doesn't come under any calculation. We do not calculate it, right? So per kilowatt or per whatever we feed back to grid, that is not calculated here. So it is completely boon.
thank you, sir.
Yeah. Yes, sir.
Hi, good afternoon, sir.
Yes, good
Sir,
afternoon.
my
Sir.
question is that you mentioned that you have a partnership with Microsoft.
Yes, yes.
So, how the Microsoft is going to help in this business?
No. We in general, in overall project, we have partnership with Microsoft. For this particular project, we have partnership with Spark. Yes. So here Spark is our partnership entity. So Microsoft is for other events or other entities.
Good afternoon, sir.
Yes, sir.
After apart from that, the grid tied inverters, any attempt or development you have tried for the grid forming inverters? It's very new technology that's coming with grid forming inverters.
Okay.
Thank you.
Hi, myself Santosh Shirwani. I take care of national sales for Geo Spark microinverter. Can you please pardon your question?
Grid tied inverters have become very popular now. It's picking up. Now there is an attempt to develop on the grid forming inverters.
So this is the type of grid forming itself, but
Uh-huh.
it is we are not giving this power back to the grid, because if we will this grid forming is comes under this battery energy storage project,
Yes, sir.
where they are generating a grid from battery and give it whatever the power is generated, they are feeding that power into back to the grid. While here what we are doing is our basic agenda is not to feed the power during the power cuts. So whenever there is a power cut comes, our conventional inverters are not functioning, or customers are losing the generation during that time, during the day. So what we have done, we are feeding that power, whatever is generated, directly to the load. So eventually you are getting emergency load, as per the radiation. So there are two types of ROI you can calculate. One there is a grid failure. At that time also you are getting the power. Again, because this is a micro inverter, so micro inverter is generally giving the power more than a conventional inverter. You are getting an additional 1 unit or 1.5 unit during the peak hours time. So you are getting higher generation as well as this dual mode feature. So it is an added advantage. This is not a grid forming feature. This is a load support
Load
feature.
supporting. Thank you very much.
Any other questions? Thank you.
Thank you so much, Mr. Deshpande ji, for sharing such valuable insights with all of us. Ladies and gentlemen, a huge round of applause. Well, to honor their valuable contributions, we would like to proceed with the felicitation ceremony, for which I would like to invite Mr. Hari Balasubramaniam, Business Development Director, Janitsa Electronics TMBH. So please join us here on stage. And I also request Mr. Sarveshwar Deshpande ji to kindly join us here on stage. I kindly request Mr. Balasubramaniam to kindly present the memento to Mr. Deshpande. Thank you so much. And now, ladies and gentlemen, we have an insightful session discussing about the energy storage and grid stability, for which I would like to invite our speakers, our esteemed panel members. Ladies and gentlemen, with a huge round of applause, let's welcome Mr. Shailesh Modi, Senior Manager, R&D, ERGA. Mr. Sanjeev Kumar, Senior General Manager, Torrent Power. A huge round of applause, ladies and gentlemen. And now let's welcome Dr. Sanjay Kumar Pradhan, Head of the Departments of International Relations, Associate Professor of International Relations, School of Liberal Studies, Pandit Deen Dayal Energy University. And now I would like to invite our moderator for this session, Mr. Satish Suri, Managing Director, Green Path Energy. Now all right. Over to you.
Good afternoon, ladies and gentlemen. So pleasure to be here today. Yesterday also we had a lot of insights and discussions on that. Now today we have the session on technical session on storage and grid stabilization or stability. So I would like to invite our speakers, delegated speakers, and Mr. Sanjay Kumar ji and Shailesh Modi ji and our university professor, sir. I forgot your name. Dr. Sanjay Pradhan ji along with us. So I would like to give a good round of applause for them. Let's welcome to the panel discussion. Sir, I would like to say one point here. So our Sanjay ji is cordially accepted for the session. Just now, there is no preparation, nothing. I requested to be here, and that is a great honor. And just give a one round of good applause to him for his gesture. Thank you very much, sir. Thank you very much.
Thank you, sir.
Sir, I understand your time limits, and you told that you have to give rush to other activities and all. So I would like to have one first question to you, sir. You mentioned that in your presentation keynote address about the critical mineral exploration. So which is a part of the competitive analysis to the China, directly and indirectly, and which includes a lot of things in the supply chain management also. And apart from that, this will be ensure the cross-functional grid stability. International grid stability also matters here. Sir, I would like to, we would like to hear from you that about critical mineral exploration. What is the, what is the expected anticipation reserves within India and unexplored reserves within India? So this is a big game changer maybe in the upcoming years and generations. So please have we would like to have some insights from you, sir, on that.
Thank you, sir. As I have told earlier, our focus till 1990s, if I'm not wrong, till 1990s it was with the oil and gas or coal-dominated energy sector. And later part, and specifically during the present government, the focus is on renewable energy. Initially, we focused on making of instruments, equipments, technological development for the parts and structures of renewable sector. But subsequently, we felt that India as a leading country needs to have sufficient critical minerals, maybe from within or getting imported. And if you go through the existing reserves, no doubt the exploration, R&D and is going on to find more and more resources. But as per the existing data and geological survey, not much resources available in India. No doubt very recently in Jammu and Kashmir some exploration happened, but some analysis it came that it is not up to high quality level. So now we have to depend on overseas countries. So when overseas countries is coming, we are looking for Latin American and Caribbean countries, Africa, then China, and to some extent it is Canada and European countries. As we see the European countries or Canada, it is competition tough and even they require much for their own domestic sector. So our focus is now for African and Latin American countries, then Chinese. If you see China factor as well as that of Latin America, Caribbean and African countries, some issues are there. Because China has a dominant, not only in exploration, but also in processing of the critical minerals. So if you are going to Africa, then you will find that the much of the mines are owned by China. So scope is not closed, but getting limited because of Chinese presence and expansion. And Africa, you will find another set of problem. For example, the most critical mineral rich in country in Africa, it is DRC, Democratic Republic of Congo. Okay. But that is totally, you can say it is passing through the civil war in one form or other. Law and order issues. And most prominently, the M23 militant group, the Tutsi group. So here law and order issue. Then comes the South African country, it is South Africa. Yes, it is a stable country. Here it is some sorts of positive expectation. Because South Africa is in G20, South Africa is in BRICS, and we have a very cordial relationship. And South Africa is one of the countries in Africa which has huge resources of critical minerals. So that is a very positive. Then Tanzania, yes. So it has the copper, cobalt as well as that of lithium. Of course, lithium is not to that level, but Tanzania we have to expect because we are very friendly towards Tanzania. And it is India's government's successful approach. Tanzania is one of the most friendly countries for the Indian foreign policy pursuits. Okay. And so these are some of the examples I'm saying. So positivism as well as some pessimism. Then, but if you are saying South Africa, China is also in BRICS, so definite competition, and South Africa will look for Chinese market as well. Then, if you are coming to Latin American and Caribbean countries, here it is the problem. Because if you see the past, we are largely cut off from the Latin American and Caribbean. Might be historical regions, ethnic regions, or that of the distance, India and LSC. But as the demand for critical minerals is increasing, definitely we will look for LSC. LSC, 3 countries, which are called that lithium triangle: Bolivia, Argentina, and Chile. That is lithium triangle. So if you are not looking for China, then we have option for Latin American Caribbean countries. We are not looking LSC at the cost of China, but alternative option as well. So, and LSC issue is there, like that of African domestic issues. LSC, they have also domestic issues. For example, they are very rigid in that tax tariff structure. And sometimes socialist governments come to power, sometimes liberal governments, so policy inconsistency. So that is a limitation in LSE. So my point, last I would like to conclude that India needs to be very assertive, because we are one of the leading countries in the solar sector, renewable energy sector, and our target is 500 gigawatt by 2030. And so far we have achieved only 213.
250 plus.
So 250 gigawatt around. So not only 50, we are looking beyond. Even Modi's vision is 2047.
Yes.
That means 100 years of
1000 gigawatt definitely could be.
So what we can achieve. So definitely, I think it is now very core to our renewable energy sector, and we have to look from different aspects, starting from R&D, exploration, processing, as well as that of the market.
Exactly.
Supply resilience. So this is my point and stake on this sector.
Sir, wonderful points you mentioned that which are unaware to the most of the audience here. One more point I would like to put it. Just I would like to know from my academic point of view, what is the mechanism or process in alternative composite materials? So because the composite materials make a lot of shift from the, because we don't have much reserves of critical minerals. Say for Jammu Kashmir, as you mentioned that quality is not up to mark, because that means the extraction cost itself will be more than the import cost. So that could be one of the reason. So in that case, from R&D point of view, because you are into the R&D activities from the university point of view, so is there any government is planning for the exploration of alternative materials, alternative composites? So like plastic, earlier we used to use plastic, there are alternatives we have. So for example, FRP. This is a kind of exploration if we have, so then these kind of barriers can be eliminated. That is what I am in the impression of that. So what do you say on that, sir? Critical mineral exploration, R&D for the composite materials or new innovative materials also? Yes.
R&D aspect, I have not gone much. So the audience, from any panelist can say on this. But one point I forgot to mention. So China is our strategic competitor. But when we are going for renewable, we have to get the benefits from China as well. Because, for example, they have huge mineral resources. To what extent we have to explore? To what extent we can get benefits? For example, if they are exploring at the international market, India can be a processor of those resources. So jointly how India and China can work, that is also important, although we have strategic competitions.
Got it, sir.
And one thing, that alternative. Yes, we are also looking for alternative. Yes, we have MSP. mineral supply partnership that consists of 15 countries. And interestingly, it is US led, and India is the only developing country MSP.
Acha.
And the purpose is how to diversify supply chain from that of the Chinese dominance. And India is also working with Japan, Australia, and some way it is through the quadrilateral security dialogue, how to have a secure supply chain for the critical mineral resources. So these are the alternatives India also looking apart from the existing scenario.
Thank you, sir. Thank you very much, sir. Thank you. Sir, now the main topic or task we are discussing about the grid stabilization and grid interconnectivity and all. So now energy storage is the instrumental instrument for the entire nation's progress on energy part. So energy security, you can say in that way. Sir Sanjeev Kumarji, so can you brief yourself and yeah, please. Sir has to leave for some other emergency activity. So if you have any questions, just please, now the floor is open for the question for him because he is having some urgent one. Mike.
First, I will say thank you, sir, for providing this type of information. So, my question is that how we can develop better technology, because you mentioned that we have a limited resource of rare materials like lithium, and that quality is not meeting as standard. So, how we are going to develop our technology? That you already mentioned that we can make component by tie up China or something like that, who having very good resources. So in India, how we are going to develop our technology in case of manufacturing, and when we can expect that yes, we are ready to emit the carbon footprints, and we are moving forward and providing a better environment, eco-friendly system in India. So how much challenges is there? I want to understand, sir. Thank you.
Okay, thank you. Actually, there is no energy transition without technology, and no technological development without the critical minerals. And if you see that of the critical minerals, all the critical minerals are not useful for the renewable sector. It is about 12 to 13 critical minerals which are used for manufacturing of the equipments. Maybe lithium, copper, cobalt, rare earth, aluminum, and copper, all these are important. And one thing I would like to, actually I have not come with the data that I have. So we have huge and mammoth shortage of critical minerals. And it is the most important, both the public sector and private sector, how we can get it. And without that, the technology or equipment we could not develop. And if you are going for Atmanirbhar Bharat or development by our own self, then we have to think over it. And otherwise, we have to just import the technologies and equipments for harnessing the natural resources. Here I find some sorts of matter that there is a gap, I think. This is my take. There is a gap, demand and supply, and that should be bridged so that our technological development will be faster on the lines of Atmanirbhar.
Thank you, sir. Thanks for your valuable insights on that. So you want to go leave for the session, sir?
Okay, thank you.
Sir, please introduce yourself and brief. then we can start the session for the technical discussion.
My name is Sanjeev Kumar, working with Torrent Power for EHV projects and working for pumped hydro storage plants. So, thanks Satish ji for inviting me for this panel discussion. And just basically yesterday also I attended this session, and we had a quiet discussion on the energy storage systems. So the need of energy storage system is becoming very critical as this renewable energy, variable energy is getting injected into the grid. So I will like to basically discuss or share my knowledge on what is the impact of the variable resources what we are injecting into the grid, how it is affecting our grid stability, and what is the need of energy storage systems.
How energy storage can give the security, energy security for the nation.
Exactly.
As energy storage, as instrument and instrumental in the system. So that is what we can.
Okay. So energy storage system basically what if you see in a grid, what happens? It is a recent experience we have in Gujarat. So much renewable energy is being injected into the grid, and what happens is that during the sunshine time, parallelly wind is also blowing, so we are unable to consume that energy. So what is the need is that once we are not able to consume that energy, we have to curtail the solar. And as per the government guidelines, solar energy cannot be curtailed. It has said for utmost priority. We can curtail thermal, we can curtail nuclear, but for solar we cannot curtail. It is the government directions. We have to. But unfortunately, what is happening is still 2 to 3% of curtailment is happening for solar as well as wind. The reason is that we don't have sufficient energy storage systems to consume that energy and store that energy, so that we can use when the solar is not there and wind is not there, we can inject back into the grid. So considering the grid stability as well as basically we have this energy storage system, like battery energy storage system is there. And what recently we had discussed, we have a shortage of these critical materials. Like lithium, we don't have any reserve. We have to depend upon the other countries. So grid stability, the energy storage system is coming from chemical as well as from the pumped storage. So this technology, pumped storage technology, is proven technology. It is around about 100 years of back. It has been already there. But unfortunately in our India, we have not explored it. If you say right now 4.7 gigawatt of pumped hydro plants are there. If we compare with China, they are the leaders for pumped storage also, and as well as US. So we come very below, and now government has recently planned for picking up this pumped storage plants, and they have a target of around about 27 gigawatts up to 2030. So once this capacity comes up, the grid stability, what happens is basically grid is frequency disturbances are there and no inertia is there from the solar. So pumped storage is a better way of handling this inertia as well as your primary resource services. Ancillary services are also there that you can discuss.
Now you mean to say that pumped storage projects are the vital and viable for the grid stability kind of, apart from the energy storage. So which will maintain the grid frequency and all. So as per your experience, how grid frequency and grid stability matters in the continuous energy energy supply system. So what is your, based on your experience on that, so what is your use on that, sir?
Basically what happens, when frequency is dependent upon the demand and supply. once you have a demand and your supply is there, you can match the frequency. And when there is a grid disturbance, what happens is that some sources go out, suddenly load comes and we are unable to meet. Then the frequency differences comes and we have a frequency band of 49.9 to 50.05 hertz. This is the frequency band where grid can be ensured. So in case sudden throw is there, sudden load throw is there, so somebody has to absorb that load. So the pumped hydro stage, what it does, it comes into a motoring mode. So they will immediately absorb the load and they will, pump up the water and they can fill up to the reservoir.
Okay.
And the speed by which they takes this action is few, milliseconds or within a minutes they come into picture. So that is the beauty of this pumped hydro storage as compared to other resources. And if you compare that, if pumped hydro storage, they have a discharge capacity and they can last up to 6 to 8 hours also.
Okay.
Unlike battery energy storage system, I am not against the battery energy system, because since we have limitations of getting battery energy systems into our India, and we have natural resources, so much natural resources are there. So we have a discharge capacity of say 4 hours or 3 hours maximum. And then again, the complete life cycle of pumped hydro is more than 40 years. We need not to replace like the batteries and all, only maintenance has to be done. And most of the technology is proven, and we can make in India also all this technology.
Okay. So you mean to say that pumped hydro storage, pumped hydro projects are alternative support to the energy storage in terms of grid stabilization.
Yeah.
So for micro level and satellite mode, BESS is there. So for grid stabilization point of view, it is a national connected kind of projects.
Because
Okay.
when we go for grid utility scale of storage, we have to go for this pumped storage, and government is very keen, and their regulatory has also brought out the mechanism
Okay.
of how to pay this renewable pumped hydro storage, means what are the services they are offering. Basically, we call it as the ancillary services. So ancillary services are how it has to be monetized. The government has clearly brought out the directions also.
Sir, I have seen that in Andhra Pradesh, there is a one Kurnool district project of 1 gigawatt pumped hydro project.
Greenco project.
Greenco, the company is operating that Greenco company. So they are into the pumped hydro project of 1 gigawatt, which is going in a rapid way. Almost 60 to 70% work is also completed.
It's commissioned.
So these are all the kind of activities are going on from the energy storage and the energy security point of view, sir. Thank you, sir. Thank you very much for your insights on that. I will come back to you for next round of questions.
Thank you.
So Shailesh ji, I would like to please have a brief introduction of yours.
My name is Shailesh Modi. I am working in ERDA, Electrical Research and Development Association, Vadodara. Basically, I am working in R&D division for the distribution, transmission and power system studies. I am looking for the protection system studies, analysis of renewable energy, power quality. And as far as the session is concerned, so it's a very good session because sir, yesterday Satish sir has spoken that by 2030, from solar and wind itself is 440 gigawatt is government plan with a total renewable target of 500 gigawatt. So it will be more than 50% of contribution from the renewable energy in next 5 years. So it's a big challenge, and so role of battery energy storage will be crucial, because we know that this renewable energy generation is variable and intermittent in nature. So we can say that it is not a dispatchable like other generations are controllable like thermal and nuclear power plant. So this is one of the challenge for the renewable energy, and battery energy storage will be a key role in present and future electrical market. And government is also supporting like other with the various government scheme like production linked scheme, then other scheme to support the manufacturing of batteries in India. It will be a project of a Make in India project. So there is a many changes in the policies and regulations. Some are already implemented and some are under pipeline to support the renewable as well as the battery energy storage projects. Apart from that, because on the next challenge of the renewable energy, we know that as sir has said that there is no contribution of the inertia from the renewable energy. You know that there is a no rotating parts. It's a converter, inverter based devices. So inertia is a key point for the frequency stability. So one of the challenge is how to provide a inertia in the system. So role of the AI system will be crucial in future power sector to find out the details on the forecasting of wind based generator and solar generator. Second is a role of some technologies like wide area measurement system and phasor measurement units, because through these PMUs, which are many places installed in Gujarat and India, so it will give a accurate results of df by dt and lower frequency nadir points, which will help the system operator how much inertia is required in the system, and based on that the system operator can make a plan for the procurement of the system inertia. Because in the future power sector, uh, inertia will be the tradable commodity, tradable parameter, just like a reactive power in present case. So now second is the reactive power support. There is almost no reactive power support on, about 5% reactive power support from renewable energy. So for all these points, the role of battery energy system will be crucial. Now many other points are there in present case also, big power plant, solar power plant. So whenever there is a no sunlight, so there is no power in the generation from the solar. So high voltage line like 220 kV lines or 400 kV lines, in the night time they are uh, there is a issue of the over voltage because of the Faraday effects, because there is a no power flow in the night time for these high tension lines. So presently utilities are managing with some devices like reactor, switchable reactors. So these are the issues for the renewable energy, and with the issues there are remedial measures and solutions are there. Battery energy storage is one of the solutions which can play an important role for the stability of the grids.
Great, sir. Great. So, inertia, virtual inertia. So, basically, virtual inertia could be one of the future leading energy market. So, that is what sir has to clearly mention that. So, of course, I had some of the insights on that projects also. But in India, I think there is, as of now, started any projects on the virtual inertia. Acha, not commercialized. Okay, okay. So maybe soon we will discuss on that. Okay, okay, sir. Okay. Thank you, sir. Thank you very much, sir. Sanjeev ji, again, when we are talking about grid stability and frequency stabilization and energy security front off. So in that, how do you see or what is your advice? I mean, suggestion or points, identified points on the from the State Electricity Regulatory Commission and Central Electricity Regulatory Commission. So these two are the governing bodies for the energy security. So how do you see the interlink and joint operation of them will ensure the grid stability and finally energy security to the nation? So what is your views on that, sir?
Yeah, very good question. Basically, CERC and SERC, these are the two governing bodies which decides the tariff mechanism what is has, because nobody is going to build any reserves or any power plant unless until they get monetized. And that too, the grid stability, this is a new market which is going to get opened for ancillary services. So CERC basically, they have their grid code. They have the Indian Energy Electricity Grid Code, IGSC there. They have clearly defined that when what are the reserves which has to be kept for the security of this grid. So there are different types of reserves which if we say National Load Dispatch Center, this is the central authority which controls the complete grid, and they define that what are the reserves in case of emergency arises, and emergency may arise at any point of time. So there have primary reserve ancillary services, then secondary reserve ancillary services, and tertiary reserve ancillary services. So CERC have the guidelines. They have issued the guidelines or the tariff mechanism in 2022. What are the, how it has to be monetized. So if we see, say for pumped storage or battery energy storage system, the trigger is the grid. Once the frequency variation comes, immediately the trigger is gone to the battery energy source supplier. So they will ask this, there will be a pre-agreement between the grid, state grid as well as the national grid, that this will be the requirement of energy reserve which may come, and you have to immediately give it to us. Okay, these are the services which are given on the primary. These are the premium they will charge. So these reserves they will keep, and once the situation comes, immediately they are being informed, and within say for example 15 minutes or 30 seconds they have to immediately respond, and they have to bring the complete this stored energy back into the grid. So these are the guidelines which CRC basically gives.
So state regulatory commission is coordinating with central regulatory commission.
Yeah.
And at the same time, if you see the, facts, so normally in India, almost 95 to 100 state discoms are under loss. It's a open, better truth. Except few state governments like Gujarat, and maybe in Gujarat also only 1 or 2 discoms in the positive numbers, and 90 to 95 discoms are under loss, under tremendous pressure. Because I worked for almost 80 to 95 discoms, I trained in a different segments in climate change and sustainability. So I used to engage with all the discom people from north to south and east to west. So I got these insights on that. And if you see that SCRC and CERC, always there will be a gap with discoms. Again, discoms are having the gap with Transco. Transco is having gap with Genco. So Genco, Transco, Discom, CERC, SCRC. So these are all the integrated part of the entire power supply system in India. So again, this has to be stabilized. So this is also one of the key point identified from the government point of view. Now they are making some restructuring and giving the, because they tied up, discoms are tied up with hands. Example I will tell you. This is for the free power, for example. The discoms hands are tied up. In that way, Transco hands are tied up in other ways. So these are all the balance, these are all the gaps are finally concluding and landing at grid instability or grid stabilization point of view, and to the finally numbers of commercial. I mean tariff numbers and all. So free tariff, free power to the, to the not only to the public, some of the sectors and all. So who will bear that? Somebody has to bear upset the load. So this is all we are bearing it. But of course that is also little bit okay. But at least technically we should have sound policy on that. So this is how the gap CRC, SCRC, discounts has to collaboratively work on that. So this is my opinion on that. So we can have, when once the floor is open for questions, we can see the questions also on that front. Here again, Shailesh, so you are R&D into the electronic segment. So power electronics and devices. So these power electronics and devices are not only for the measuring the numbers. Of course, measuring is a part of our fundamental primary activity to upgrade ourselves. So in that case, power electronics and devices, how they can impact in a positive way and negative way. So I would like to hear from you on positive side and negative side also. So please have a
We know that as the power sector is growing, so these power electronics devices, it may be series devices or shunt devices, role is becoming crucial. And in future also, these power electronics devices will be very important role. Now there is some series devices, some parallel devices. So there are different applications like thyristorized control series capacitor. It will help to increase the power transfer capacity between two bus. Like SVC, static wire compensator. It is used for the voltage control. It may be on the lagging side or leading side. Similarly, STATCOM. Nowadays, uh, installation and commissioning of STATCOM is increasing compared to past years because there is a more challenges with respect to these power quality parameters like harmonics and negative sequence voltage and currents. Now, as far as the STATCOM is concerned, uh, compared to SVC, this dynamic response of the STATCOM is important. It's very good response. So prefer to SVC. So we prefer a installation of STATCOM for remedial measure of power quality. Now, in future also, because uh, as renewable energy generation will be at a spreaded place. So now to feed the renewable energy into the specific transmission line, so this power electronics device will play a important role. Now second point is said disadvantage of power electronic devices are that they are sometimes they are polluting the grids, like they are responsible, like inverter convert type of devices, they are responsible for generating the harmonics, and CEA regulations are there. uh, it regular interval of time, it is mandatory for industries and captive power plant to measure the power quality harmonics and DC current. So, second point is that I would like to add that many these devices like series capacitor or thyristoride series control capacitor installed before 20 years, 30 years. Similarly, like a power system stabilizer for a big size generator, these control parameters are modeled and finalized at that time of time. Now, before 30 years, 40 years, I think every 5 years they are doing the planning study, but I don't think they are changing some basic control parameters of these power electronics devices. So what I will say that it is a requirement for nowadays for a growing power sector to review these control parameters every 3 to 4 years uh, to have a good performance and security of the power system grid.
the harmonics are the one of the critical component for the energy security because harmonics in industrial energy audits, if you see, around 2 to 3% of energy waste or energy losses are happening through the harmonics. So this is a statement, I mean, this is studies say that. So that means harmonic filters, harmonic analysis and harmonic filters will make a lot of role. And is there any, I mean, is there any product when we are getting the appliances or any equipment for certification or testing purpose, is that come with inbuilt of harmonic filters, harmonic mitigation system or not as of now?
Sir, if there is a predominant harmonics component like a third harmonics, so based on that particular harmonics, we can design a filters like active filter,
Okay.
passive filter to mitigate the harmonics.
Okay, so inbuilt can be
So
possible.
based on this measurement of the power quality parameters, and in more of the cases, loads are the responsible. Apart from these devices, sometimes loads are also important for polluting the grids. like some non-linear kind of loads,
Okay.
like a rolling mill or arc furnace. They are polluting the grid much.
Acha.
So based on these measurement and system studies, I think better to design a this harmonics filter.
Okay. So, but harmonic filter inbuilt installed equipments are not mandatory in India? Not mandatory as of now?
Uh, I don't know much of on that, but how?
Sir, please, sir, please. Yeah.
Sorry to take over from here. So this, as far as harmonics is concerned, that there is already a regulation placed in India for IEEE 519 to follow for majority of the HV industries. But regulations are yet to be placed by the state regulators. So only few regulators have taken some actions on this. Even though CEA has initiated this in 2017. So it's still ongoing process in India. But harmonics, in fact, that was my next subject also when I'm going to talk. It was more or less relating to that. Harmonics as a subject, industries are yet to embrace the standard. It's very important because we need to first to say that yes, I will accept it, and then let's start following this practice. It is not yet come. In fact, rather it so happens it has to be pushed with a regulation and say, if you don't do it, I will punish you. So this is the way we are right now going towards the direction. But it has to be embraced by the industry, by themselves. Then we can also be one of the most developed countries. That I'm very sure on this case. But that's about the harmonics which I can talk about. But it is very, very difficult because the grid system is changing very drastically for us. It's very difficult to have proper control at any place. And it is not one medicine for all the places. It depends on the load. It depends on the place where they are in the grid and things. That's it.
Cool, sir. Thank you very much. Thanks for your insights again on that harmonic filters, mitigation planning and all. So now continuing to the subject. So for grid stabilization and energy security for the nation, we are always focusing on the technology front. Maybe harmonic filters point of view or BESS or new innovations and so many things. And there is a hidden treasure called safety aspects. So safety aspects also primarily important because this should start from your OEM equipment to the installation, operations and maintenance and for the continuous improvement. So in that there are a lot of standards are there, IEC standards are there like 61215, 614116. These are all the standards not only meant for the operations, and it is for the equipment manufacturers also. So this is the stage where we need to focus on that, and of course our CPRI is also part of that standards development and all. So how we have to enhance the standard qualities and safety qualities of the product. When once all products are compliant with all the standards and safety standards, then the equipment can run for efficiently. So, and it will not give any imbalance in between and during the operations of time. So this is a part of our safety standards. And apart from that standards of equipment and all, there is a National Electric Code also. NEC standards also to be maintained for all the manufacturers. So now all the panel manufacturers and module manufacturers, cell manufacturers, and all the component manufacturers which are here, they are also completely aligned with, they should align with all the kind of safety protocols and standards as per the international standard and as per the BIS standards and as per the NEC standards also. So this is one of the important point. Normally it is a untouched kind of area for the discussion. And again, testing protocols. So CPRI is one of the major India's leading testing protocols development for the equipment and as well as to the process also. So protocols are required not only for the equipment, for the process also. So how the SOPs can be established. So based on the our experience or issues we addressed earlier, So failure mechanism. So what are the major learnings from the failures? Also, we can go for the CPRE standards and all. So that is safety protocol standards development, also part of our renewable energy integration plan for the national energy security. And again, of course, last but not least, fire safety and security. So it is one of the washing subject kind of thing. So this is I want to touch upon that fire safety and security also part of our should be our part of our daily life. Let us forget about energy storage. We just forget about it. So safety and standards should be part of our life and our lifestyle and to the next generations also in that case. So this is how the system and integrated. So because all these integrated mechanism will give the grid security, grid stabilization and national energy security. In this link, even one chain of link missed also, we saw how the we experienced that how the losses will be there. So this is the session would like to conclude here itself. And anything, if you want to share anything, sir, you can share for 1 or 2 minutes. We have some time, or we can open the session for the floor open for the questions. So now any questions? Floor is open for that.
Hello. My question is to Mr. Sailesh Modi regarding the power electronics. There are two components, active and passive. So passive component generate the harmonics, and they may affect the. How can we improve the power? How can we nullify the harmonics to improve the power quality? By verifying the harmonics, then power quality improve.
As I said earlier, apart from devices, nodes are responsible for the harmonics. So I will say that one is the devices which can help to mitigate the harmonics like active filter, passive filter. Now second part is that now that's why some of the power plants, captive power plant, they opted to connect their power plant to the utility grid. Because, and you know that there will be some for that parallel operation charges levied. Apart from that contract demand charges and energy charges. Because when they operate their generator along with loads with utility grid rather than isolation, so biggest advantage is the higher fault level. So when they operate their plant with higher fault level capacity of the utility grid, so the impact of this pollution like harmonics towards this captive power plant generator will be less. So they prevent their equipment from such type of harmonics by connecting their power plant with the utility grid. But of course, if there is some loads like as I said arc furnace, so it is mandatory to provide some mitigating devices like a filter to remove the harmonics.
Yeah, hello. My name is Dr. Harsh Sethi. A very insightful and very good session. My question is to Mr. Sanjeev Kumar. Sir, you said about pump storage for energy storage and grid stability. Currently, Indian government has proposed about 10% as BESS battery storage for grids. Now, if we look at the MNRE projections or Government of India projections for by 2030, we are looking at something like 400 to 500 gigawatt of installed capacity. In that context, what do you think would be sustainable as far as cost and maintaining our renewable energy targets? Is it BESS or is it pump storage? And will it work to that level? That's the question. Thank you.
Thank you. Basically, if you see the targets which ministry has set, total round about 74 gigawatt of storage system that will be divided between pumped storage as well as battery storage. So around about 27 gigawatt is coming from pumped storage that has been already pipeline. Means if you say already construction is going on, as well as some of the plants are about to get commissioned. Major players, basically Adani is there, JSW is there. Now Torrent has also entered into this, and they will be having a 3 gigawatt of pumped storage plant in Maharashtra, Karjat. So this project is already going on, and if you see battery energy storage system, it is slightly higher side than compared to pumped storage, and the rest of balance, say about 74 out of 27 will be pumped storage, and the balance will be coming from battery energy storage system. The good quality of battery energy storage system is that you can immediately install it. Only thing is the limitation is coming of the rare materials, which we have to again depend upon China. They may twist your arms any point of time. This is happening, and we are seeing also. So we cannot avoid pumped storage, and government is very keen to as the legal processes are also very smoothened, as well as the tariff mechanism is also very smoothened, and private players are right now. These all private players are coming after the policy change which government has adopted. And the good thing about this, our government, Mr. Narendra Modi, is aggressive on this, and we understand the energy security and 100 years, 47. So I think this capacity will grow up to this pumped storage will go much bigger capacity. We are very lagging in this, and we don't have any other option. We have to go for this pumped storage and battery energy storage system right now. And hydrogen storage, this is also, green hydrogen is also coming up, but we are in the very nascent stage. And again, technology is dependent on other countries. So we have to balance between the technologies which we can, make ourselves and not depend upon other countries. So we have to make a balance between these two. I think battery energy and pumped storage will be the future of this energy storage system.
India's, green hydrogen target set by around 150 million metric tons per annum by 2030. To achieve that, for green hydrogen status, we require standalone power of 125 gigawatt. So that means out of 500, 1/4 will be taken by the green hydrogen project itself. That means it is a in depth. There is a lot of scope. So, sir, one point just I would like to ask you: energy storage or pumped storage? Which one is cheaper? Simple way. I don't want all the calculations and all. Which one is cheaper? Just for the, for the basic idea of that.
Pumped storage and energy, basically it is one form of storage only. We can say battery chemical is there, and this is a
Kinetic energy storing, that is the chemical energy storing. Simple difference.
Yeah, water battery. We can say it is a water battery.
Yes.
You pump the water and you store it, and that water when flows down, it creates the electricity. So it is a water battery.
Right.
This is a chemical battery. So
cost wise, per unit landing cost, approximately which one will be the cheaper?
Yeah, better way to compare this technology is the levelized cost of storage, LCOS, which we say. We cannot compare the battery energy storage system by the capex what it is incurring compared to the battery this pumped storage, because that is in megawatt and this is in kilowatt hour. So if we see the LCOS of both, the still pumped hydro storage, because pumped hydro storage is having a this complete 40 years of
lifespan.
So that way the levelized cost of storage gets reduced for pumped storage as compared to battery energy storage. Still, once battery energy more technology comes and the price goes down, maybe it may become compared to.
So basically, pumped storage is a mechanical system.
Yeah.
Battery storage is a chemical, electrical, electronic system. So that is the differentiation. And if you see the pumped storage cost, the capex cost is more and operational cost is less. Whereas in BSS, operational and I mean, capex cost is similar to that. And again, the problem, I mean, the negative aspect from this pumped storage is environmental impact assessment. Again, rehabilitation of the entire villages and all. No, so that is one of the complex situation. But of course, by God's grace, all our Indian locations, wherever the hydro plants are there, are already blessed with these kind of non-living spaces. So that could be one of the thing. But of course, always challenges will be there. Suppose, for example, in Andhra Pradesh, if you see Polavaram mega project, so they have to rehabilitate around 150 villages. But of course, it's a once in a time, but it's a lifetime project. So this is the plus minus will be there. Even if you see Bhakranangal project, that time also these things happened. Any project, Sutlej project, the same thing happened. So in pumped storage also, this could be one of the challenge. So, but of course, we have to run as per the water flows. So there is no other way on that. Thank you, sir. So any questions, please?
Yeah, not a question, but I would like to continue your you said that the safety and reliability, because in India, the all manufacturer want to become billionaire on the single day or single click of your mouse. So presently you are not talking about the safety. So whatever you said, the testing is very important for the safety and reliability point of view. In pump hydro also you talk about the price or cost, but whenever you look at the 40-year span, then it will be the more economical and having the more reliable solution. So for the safety and reliability, testing must be required. So the awareness between the manufacturer, because आज के डेट में सब लोग ट्रेडर बनना चाहते हैं, इधर से आइटम उठाया, यहाँ पे नेम प्लेट चेंज किया और बेच दिया. These are the things now the Indian mentality. We don't have the research and development in the industry. आप industry में आज पूछोगे, then what is their percentage of expense on the research and development? But mostly there is a nil. So if you want to compete with the China, then safety and reliability must be in the one factor. Also the research and development, because sustainable energy is sustainable, but our growth is not sustainable. Today, if we have some conflict with the China, then we'll be no more. So thank you, and you valid your point were valid for the safety and reliability. Thank you.
Thank you, sir.
I have a follow-up question. Actually, recently China tested for pumped hydro for 1,000 feet, and they could achieve something like 1 terawatt hour capacity. And they say that it would change dynamics of the renewable energy in total. What levels are we talking about when we talk about storage in India?
In India, as I said, the maximum capacity which is already means if we talk about the potential, it is having 198 around about 198 gigawatt of potential is still there, and we have explored only 4.7 gigawatt. So you can imagine how much potential is already there. And compared to hydro projects, there is very less rehabilitation required, because we have a reservoir already on the upper side, and lower side also we have the reservoir, and in between we have to connect these two through the pipeline. This is the only, and somewhat environmental disturbances comes like during the construction period, you have to transport the material, and dusting will be there, and some forest deforestation may happen, but that will not be at the cost of what we are looking for, the grid stability. China is having a huge grid, and if you can imagine, within 2030 they are planning for 5 years, they are planning 120 gigawatt, and we are talking about only 24 gigawatt for that 5 years, because still we are in a mode whether to adopt it or not, or the taking of decisions. So long only 5 gigawatt we have achieved. So there is a huge potential, and we should go for it.
For the hydro, I think sir said that the capacity is only because of the head, because in hydro also there is a higher head type of pumping storage, lower head type also, but that the multiplication of a head versus your capacity, with the volume of the water per second or per meter cube per hour, and the head. And different type of the pumps are available, axial flow and vertical means vertical flow, so which can accommodate either higher head or lower head. So that is depends on whatever the area, catchment area available for putting your water back to the your reservoir. That's
Beauty of this pump hydro storage is that the same generator which is generating electricity, it will work as a pump, and once the connections are reversed, that will act as a pump and it will pump the water to the higher level, and it will generate the electricity during when it is required. And it is green energy is used, like you have to mandatorily use the solar as well as wind energy from the grid for pumping. So they are not using the thermal energy, and that way the carbon footprint, or we say the carbon emission, is very less as in this pumped hydro storage.
Thank you, sir. Thanks to all the panel members for having this session in a very delightful way and a very spectacular way also. So I would like to have a concluding remarks on that. Thank you very much, sir. Thank you.
Thank you so much, Mr. Suri, for leading this session wonderfully. And a big thanks to all our speakers for sharing such valuable insights, ladies and gentlemen. Let's make a big round of applause. Right. To honor their valuable contributions, we would like to proceed with the felicitation ceremony. So I would like to invite Mr. Hari Balasubramaniam, Business Development Director, Janitsa Electronics GmbH. I request Mr. Shailesh Modi, Senior Manager R&D ERDA, to kindly move forward. Now, I kindly request Mr. Sanjeev Kumar, Senior General Manager, Torrent Power, to kindly move forward and accept this felicitation award. Now I request the entire panel to please come forward, come together for a group photograph. Thank you so much. Now we have another session with Mr. Hari Balasubramaniam, Business Development Director, Janitsa Electronics GmbH, under the topic Smart Grids and Digitalization in Power Distributions. This keynote session will explore how smart grids and digital technologies are reshaping power distributions in India. Mr. Balasubramaniam will discuss advanced grid infrastructure, real-time monitoring, AI-driven analytics, and the integration of renewables. We will also learn how digitalization enhances grid reliability, efficiency, and resilience while paving the way for a more flexible and sustainable energy future. So everyone, please make a big round of applause as we welcome Mr. Hari Balasubramaniam.
we were talking about capacity. We were talking about volume of energy. Now we will talk about quality of power. So it's everything combines together, right? Quality is not a neglected subject. So we also take on this right now under the smart grids and digitalization topic. Usually what happens is a centralized grid is something like this, where a generation happens, transmission, and then it hands over to the distribution and then to the consumption. So it used to be the case few decades back. But now what has happened here is it has come down to generation, transmission, distribution, and consumption. And every stage we have a generation, and every stage we have a storage as well. So it is getting complex and mixed, meaning it is getting decentralized, and the supply energy flow is becoming bidirectional everywhere. And then there is a power exchange happening. And then it is very, very highly dynamic and complex. So the power is not flowing from top to down, but it is spreading everywhere and in all directions. That's what is happening. And that's what this picture clearly depicts as well, for you to see and understand this. So what it requires, what it needs to be done, because everything is fast. Everything is fast here. The energy flow of direction changes very quickly. Maybe for a small, very short periods, it gets changed. So what we need is very, very important fast action and fast communication from anything and everything what is happening on the network. So that becomes very important, and that's why we are all trying to go behind smart grid, right? Smart grid is nothing but the data what you get is fast. The data and also the action what you take can also be faster enough to mitigate any kind of risks what is coming on. To do this in the standards from generation to consumer side, there are quite a few standards are already in place, and that standard needs to be followed. So that's why I always insist on, if everyone follows standards, then the life becomes very easy for everyone. If everyone don't follow the standards, the life becomes very difficult. At home also, if everyone are getting up in the morning at the same time, then the housewives or the people who are taking care of the home, it becomes very difficult, very easy. But if everyone starts at one time, someone working night shift, someone coming back from the night shift, then the whole home becomes haywire. The same example for the grid as well. So if everything happens smoothly, it's fine. But if it doesn't happen, so that is why we need to follow standards in this case. Yeah, following standards becomes very important, because standards gives us limits and thresholds up to how long we can go, how far we can go in doing something wrong. You know, it is rather, I would say, doing something wrong you can go. That's where we are having a limits onto it. So a standard is usually a document which provides requirements of specifications and guidelines. But when it comes as regulation, then it becomes much more serious. So it's the same thing. I always compare what happens at home, right? So the regulation means if someone comes and says, yes, this is what you are going to do, if you are not following it, you will be penalized. Then that becomes, the regulation takes the front stage. And then when it starts getting enforced, the problem becomes more severe for as a consumer or as a prosumer in a way. So it becomes very, very important that we follow the standards in this case. Actually, when it comes to the power quality, I'll be finishing it off in a very short time because of the audience, plus also the time for lunch as well, right? So you have quite a few power quality issues of long-term frequency variations, voltage variations, current unbalance, flicker. Flicker is related with voltage and current harmonics and interharmonics. So quite a few amount of PQ problems which we foresee or which exist along with the grid. Why? Because we are having a very dynamic grid. And since we are having a very dynamic grid, even the short circuit levels at various points of your grid is also dynamic. Maybe at the time of calculation of a substation, we will create a calculate for a short circuit level, but it may not be the same after around 10 years or 20 years of service, then where we have got more number of solar power coming in, including the homegrown solar systems, then the naturally our short circuit levels vary and fluctuate very rapidly. So that's very important. And that also creates an important aspect for creating more harmonics in the system also. So that becomes very important for us to note. In such a wide scenario, we have so many parameters. Now we are all coming up, okay, what do? We need to measure, where to measure, what to measure, when and how do we measure these systems? This is it becomes very important in this case of how the measurement of harmonics or power quality happens. So keeping that aside, I wanted to talk about few of the power quality issues happening in the solar plants. So this becomes very important. Voltage fluctuations. First of all, before this, I will tell you one more important issue, and I always talk to this. We had one of our customer was managing a 500 kVA power plant. They were very happy that they were doing a 500 kVA power plant and they were using it. We said, okay. Then then they came up to us and we wanted to see after 5 years of service, how much effectively I am using this. Then we started taking the records with our devices, because it has been all the way there with our software and stuff like that. We found they have as an average in the last 3 years, in a month, 120 minutes, there is no power supply during the daytime. As an average, 120 minutes, they don't have power supply in their plant, for their plant. So they don't generate. They don't import from utility. They're running it on generators. And they wanted to expand. Then I asked him, if you were wanting it for that almost 4 or 5 days in a month, you literally don't have power supply as an average. And then you wanted to have more and more power plants like this, whether it is make any sense of doing this. This was a question which I asked. So availability of voltage becomes very important in solar stations. And that needs to be monitored. And that is why we have SAFE and our IS 17036 standards coming on. So we need to follow that. Point number 1. Point number 2, we have voltage fluctuations or enormous depending on the area. If it is slightly in the rural areas, you get it only at 190 volts on per phase voltages. Sometimes you come out, some places you are even getting at 280. Someone said, more solar plants coming up, it increases my voltage level on the grid also in certain places. So this fluctuation needs to be monitored, and this cannot be for always the measured level by a normal devices. It has to be measured at higher end devices, which these sags and swells can go as low as 10 milliseconds to 1 second very easily. And this needs to be monitored as well. Second part is the harmonic distortion by itself. As we all just spoke about harmonics, harmonics is a subject that it is injected by the loads. We are all knowing it. Traditionally, what would happen is we had thermal generators, which was generating a pure sine wave and injecting power. And we are very sure it is the consumer who is injecting the active harmonic component. But unfortunately, now you also have solar power generations, which comes up with steps. They don't give a pure sine wave, but they give a small steps if you observe the sine wave. So that also adds up to our firmware. So ultimately, it distorts the generation as well. So it depends. So we need to be more giving more importance to the voltage harmonics at every level. In fact, today, if any semiconductor industry or an electronic industry coming in asks for a voltage profile from the utilities, but many utilities do not have proper voltage profile with them to show it to their customers. Then we talk about the voltage imbalances. We talk about DC injection, again, as we spoke about just now. Voltage imbalance becomes very important because we don't provide 5 wires to the homes. We still provide only 4 wires to the homes. So that's again a cause of concern. And then the frequency deviation. In fact, as far as frequency deviation, I should say that in India, we have come far away for a betterment in the last 2 decades or so. Otherwise, we were always having, I still remember in Tamil Nadu, when during an off season during wind seasons, everyone will be monitoring the frequency very closely, because if the wind stops there in the coastal side, then the frequency also does a swagging from top to bottom like this. So it's always important to know the frequency deviations and monitor it continuously. Of course, transient event happens because of solars also. So these are the common power quality issues happens in the solar plants, and the effects is very, very big. Very, very big, because it creates inefficiencies, it can provide penalties, it can damage the equipment, not only from the solar side point of view, but also for the loads of the customers as well. Of course, it raises at last the reliability concerns on this particular subject. So in total, if you look at it, the harmonics, especially, we should start monitoring the voltage more often than just seeing the needle where it is in the devices. It becomes very, very important. We need to be analyzing the voltage. All our institutions on these I would place a request today to ensure that we do more work on this, on voltage monitoring of the grid at various levels, so that we get a clear picture of how each one are interdependent at each level. This can help us in understanding better and make our grid much more stable. Because as he rightly put it, it is estimated the PQ problems in industries in Europe and US is almost cost up to around 190 billion US dollars every year. The losses, the losses is not only because of the power side or energy side, but it is because of the production and production losses and everything put together. It is a colossal waste for the economy itself by this way. But we need to be monitoring. Voltage monitoring alone can do a lot of good in reducing this, because right now what happens is, today in an industry, if something fails, someone goes, switches on, problem solved. No, the problem starts from there. So this is what happens, and we need to start monitoring these kind of many industries where we go currently in the present days. We find this, but they don't know how to explain the problem to the authorities. This is very, very important. If I have enough data to show that this is what is the trouble I am having as an industry, then only the utilities or anyone whom you're going and complaining will be able to take action. A normal letter of complaint will not help. That's what I mean to say. So it becomes very important that we start collecting fundamental data and then start working on that to ensure our grid is much more safer. In all other words, I would always say power quality is about a big elephant. It's not about part of an elephant. So we need to be ensuring that power quality as a complete subject, and then we should start taking on the power quality as a whole. Thank you very much for listening to me, and thank you very much. Any questions I have? Good. Yes. No. Right.
So voltage issue.
Could be. It could be helpful for voltage issues, because especially on the low voltage side and right through voltages, what you are asking about, that happens when there is a switching happening. But even otherwise, there are quite a few places in where there are feeders. Say, for example, there may be a substation connected to a pharma industry and also to an iron and steel industry. A furnace coming on can affect the pharma industry on the other side. So this also has to come onto the design, because the pharma industry, the effect of voltage going low can be much more worse than for the iron and steel industry. But iron and industry is the creator of the problem probably. So these things needs to be analyzed at the time of design of the substation itself, and where the power is subsequently given and stuff like that. It can take into effect, but I don't think it will be to that effect, because it is much more parameters are involved in the voltage fluctuations. Only on the, maybe Sanjeev sir should be able to also put some lights onto that actually, on the voltage, especially on the voltage fluctuations. What in our experiences it says is it happens at 33 kV level, it happens at 66 kV level. When there is a long overhead lines, we still have these problems of sags and swells. Then someone comes and trims the trees around the overhead lines, it solves the problem. So there are quite a few environmental actions also needed, especially when there are a lot of overhead lines going on in this case. So that's how it matters.
Okay, thank you. Thank you.
Thank you.
Thank you so much, Mr. Hari Balasubramaniam, for this wonderful presentation. Well, now, ladies and gentlemen, we'll take a break for lunch. Thank you so much for being a wonderful audience, and we'll see you right back at 2:30 p.m., where we'll be doing the award ceremony. So I request you all to kindly join us for the award ceremony by 2:30 p.m. Until then, use this opportunity to connect, to exchange ideas and make connections that last beyond this conference. Thank you so much.
Yeah. चलो बंद कर लो.
25.
चालू नहीं किया है ना भाई. हाँ.
Good afternoon, everyone. I request all the exhibitors, all the visitors, and our esteemed guests and respected dignitaries to kindly join us at the conference area. We're about to begin with the award ceremony of EPS EXPO 2025. I repeat once again, I kindly request all the exhibitors, all the visitors, our esteemed guests and respected dignitaries to kindly join us at the conference area. We're about to begin with the award of EPS EXPO 2025. Thank you so much.
आता मैं वापस काम करके वापस चले क्या बोलेंगे आज अपने प्लेस पे ले तो हाँ तीन सौ के प्लेस पे तीन सौ के प्लेस पे कौन कौन मिला आगे और क्यों यार वो
Good afternoon, everyone. I request all the respected dignitaries, our esteemed guests, all the exhibitors and visitors to please kindly join us at the conference area. We're about to begin with the award ceremony of EPS EXPO 2025. I repeat once again, I request all our esteemed guests, all the respected dignitaries, all the exhibitors and visitors to please kindly join us at the conference area. We're about to begin with the award ceremony of EPS EXPO 2025.
पॉसिबल तो करना पड़ेगा। क्या कर रहे हो? अरे पप्पा बोलो, पप्पा 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 बोलो, अरे पप्पा बोलो, पप्पा पप्पा। हाँ पेकेट खाते जब भी अपने खिलाते हैं में पेकेट तो भूसे कसूर नहीं, हमें आज तो कोई खिला रहे थे पानी नहीं। हाँ बेटे बोल, हाँ बेटे बोल। पापा आइसक्रीम खा रहा है, पापा आइसक्रीम खा रहा है, पापा आइसक्रीम खा रहा है, आइसक्रीम खा रहा है पापा। आएगी आएगी आइसक्रीम नाउ। इन्होंने यही तो मोटी करी है सर, प्रस्तुत एक तरह फिर हमारा टाइम मतलब नहीं, अरे परसों के मैं टाइम बांध रहा ठीक है। ये आज बहुत ज्यादा पाउडर लगाते हैं मम्मा ने बहुत पाउडर लगा दिया मेरे को। हाँ ज्यादा लगा दिया मम्मा ने पाउडर, है ना। कैसा रहा स्वागत? भाई क्या कलर है तू? अरे घूमने करने जाना है, गाड़ी लेके आए। खिला रही है शोर पर। अच्छा कर अच्छा कर अच्छा कर अच्छा कर दे अच्छा कर दे। में रखी मतलब सबसे बात मैं बाय बाय बाय। अरे ऊपर तो संदेश मारती खबर पड़ी समझ चालू रखो ना, कभी भी चालू हो जाए। चार बात हमारी जोड़ेगा
Good afternoon, everyone. I kindly request all our esteemed guests, respected dignitaries, and all the exhibitors and visitors to please kindly join us at the conference area. We're about to begin with the award ceremony of EPS EXPO 2025. I repeat once again, I kindly request all the exhibitors, visitors, our esteemed guests and respected dignitaries to kindly join us at the conference area. We're about to begin with the award ceremony of EPS EXPO 2025. Thank you so much.
Yes.
Good afternoon, everyone. Welcome to the EPS EXPO 2025 award ceremony. We have gathered to recognize and celebrate the outstanding contributions, innovations, and achievements in the electrical power and solar industries. As we come together to honor the best in our field, let's take a moment to appreciate the dedication, hard work, and passion that have brought us to this moment. Your commitment to excellence has not only driven innovation, to also inspire others to strive for greatness. We will recognize the winners of various categories, showcasing their talents in this industry. Let's give a warm round of applause, ladies and gentlemen, to all our nominees and all our winners in advance. Let's take a big round of applause as we start the award ceremony. So the first category, first award that we have is the Sales and Strategy Excellence Award. And that goes to Mr. Bharat Singh, TM, Director, Sales and Marketing, India, North Africa, Ningbo Die Inverter Technology Limited. Ladies and gentlemen, a huge round of applause. And to present the award, I would like to invite Mr. Hari Balasubramaniam, Business Development Director, Janitsa Electronics TMBH. Well, this award recognizes the outstanding achievement in driving business growth through innovative sales strategies, market insights, and execution excellence that set new benchmarks in the energy sector. Well, ladies and gentlemen, let's welcome Ms. Shivani Thakur, Head Products and Solutions, and Ms. Rakshanda, Head Sales and Marketing, to receive the award on behalf of Mr. Bharat Singh. Can we make a huge round of applause, ladies and gentlemen? Come on, let's keep the energy high. Ms. Shivani and Ms. Rakshanda, would you like to say something on behalf of Mr. Bharat? Everyone, a big round of applause for Ms. Shivani.
Thank you, EPS EXPO, for organizing such an amazing expo here in Ahmedabad. We are looking forward for more expo pan India, and thank you so much for this award. Thank you.
Thank you so much. Well, the next category that we have is the Best Partner Product Certification Advisor for Solar Industry. Here we are recognizing the Best Partner Product Certification Advisor for the solar industry for their trusted guidance, expertise, and invaluable support in driving quality, compliance, and growth within the solar sector. Well, this award goes to Hind Solar, ladies and gentlemen. And to present the award, I would like to invite Dr. Anand Kumar, Joint Director of CPRI. Now, I would like to invite Mr. Pranav Mukherjee, Chief Technical Officer, to receive the award on behalf of Hind Solar. Ladies and gentlemen, please put your hands together. So the next category that we have is the Top Emerging Solar Company. Here we are honoring a dynamic and innovative solar company making remarkable strides in growth, sustainability, and shaping the future of clean energy. And to present this award, I would like to invite Mr. Hari Balasubramaniam, Business Development Director, Janitsa Electronics TMBH. So, ladies and gentlemen, please put your hands together for P Solar Consultant and Engineer Private Limited. And Mr. Anil Gupta, the Managing Director, will be receiving the award. Ladies and gentlemen, let's put your hands together. Come on. Let's keep the energy high and congratulate all the winners. Mr. Anil, would you like to say something to our audience?
Awards are like booster dose, which gives the inspiration for next.
Definitely.
Thank you.
Thank you so much. All right, the next category that we have is the Renewable Energy Leadership Award, where we are recognizing the exemplary leadership, vision, and commitment in driving innovation and growth in the renewable energy sector. And to present this award, I once again request Mr. Hari Balasubramaniam, Business Development Director, Janitsa Electronic GmbH, to please come forward. Ladies and gentlemen, Renewable Energy Leadership Award goes to Power Track Group. Ladies and gentlemen, please put your hands together. Mr. Deepak Lodhe, Director. All right, so moving on, the next category that we have is the Next Gen Energy Innovation Award for pioneering innovations shaping the future of next generation energy. And the award goes to Nova Next Energies Private Limited. Ladies and gentlemen, please put your hands together as we welcome Mr. Shabir Makati, Mr. Habib Pipamentwala. Huge round of applause, come on, for Mr. Shabir Makati, founders and CEO and director, and Mr. Habib Pipamentwala, CEO and director. Mr. Shabir and Mr. Habib, would you like to say something and address to our audience? How do you feel after receiving this award?
Well, it's a great honor to receive this award on behalf of Nova Next. It pushes us more to do in the field of innovation. As our name suggests, Nova Next. We are always looking what is the new next, and we are always future oriented in our approach. Thank you.
Thank you so much. Thank you so much, Mr. Habib. Thank you so much for the award. And before moving on, I would like to say, let's bring back the energy that we started yesterday with, because I see there is a downfall in the energy, and we can't move on with this kind of energy further, because all we're discussing about energy, right? And still we can't see any energy in this room. So let's create some energy, right? I want to know, like, how are you all doing? Are you all doing good? Are you all doing good? I can't hear you. Are you all doing good? All right, let me just do a quick vibe check so that we know we're good to go. All right, so all those who are doing good, can you please raise your right hand like this? Perfect. Now keep the hand raised. Come on. Don't close it. Okay. Now all those who are doing better, can you please raise your left hand as well like this? Perfect. Now all those who are doing awesome, can you please join your hands together and give a massive round of applause? Come on. More louder. Come on. Thank you. Fantastic. So continuing with the award, the next category that we have is the Solar Energy Pioneer Award, where we are honoring the visionary leadership and groundbreaking contributions that have advanced the growth and adoption of the solar energy. Well, to present the award, I would like to invite Mr. Manoj Kumar Singh, founder and CEO, Net Zero Think Private Limited. Give him a round of applause, come on. Same energy, guys. Technology Pioneer Award goes to Trinano Technologies Private Limited. A big hand for Trinano Technologies Private Limited. And let's welcome Mr. Abhijit Balakrishnan, Manager, Research and Development, to receive the award. Come on, everyone. Let's give them a big round of applause. And Mr. Abhijit, would you like to say something? We are expecting you to say something about, like, how do you feel after receiving the award and about the EPS Expo as well?
First of all, thank you so much for the great opportunity. It's really amazing the program that was conducted. And I would like to dedicate this award to all Trinano team, for especially my colleagues, team members. Thank you so much.
You're welcome. Thank you. So the next category that we have is the Leadership Excellence Award, which is awarded for the exceptional vision, integrity, and leadership excellence. And the award goes to Mr. Kumar Abhishek, Regional Manager Sales, Bomb Systems and Services Private Limited. Let's give them a big round of applause, ladies and gentlemen. Come on. Let's keep the energy high once again for Mr. Abhishek Kumar. And sir, would you like to say something to our audience?
Thank you, Energetica and team Hardik for this wonderful event and giving us opportunity to put our stall here. So we have explored a lot of much for the customers of these segments as well. Earlier we were not here. Now we are planning to establish our branch and everything here because we have got very good response from the market. Thank you so much.
You're welcome. Can we make a round of applause? Come on. And thank you so much, Mr. Manoj, for helping us through the award ceremony. So the next category that we have is the Outstanding Contribution to Solar Power Growth. This award honors exceptional efforts in advancing solar energy adoption, driving large-scale deployment, and contributing significantly to the growth of solar power sector. And to present this award, I would like to invite Mr. Hari Balasubramaniam, Business Development Director, Chalitza Electronic GmbH. So the award of outstanding contribution to solar power growth goes to Sunbond Energy Private Limited. Ladies and gentlemen, please put your hands together for the team of Sunbond Energy Private Limited. Mr. Bhavya Patel, Chief Strategy Officer, has come up to receive the award. Let's take a big round of applause, ladies and gentlemen. Come on.
Hello.
Mr. Patel, how do you like the EPS Expo 2025 and what is your experience here?
First of all, thank you for having us, and it was a great experience. And we would like to just say that someone is here and it's gonna stay. Thank you so much.
Fantastic. Thank you so much, ladies and gentlemen. Once again, a huge round of applause for Sunborn Energy. So the next category that we have is the Energy R&D Excellence Award. This award recognizes outstanding achievements in energy research and development, honoring innovative solutions, breakthrough technologies, and impactful contributions that drive progress in the power and clean energy sectors. And to present this award, I would again like to invite Mr. Hari Balakrishna Subramaniam, Business Development Director, Jalitsa Electronic GmbH. And ladies and gentlemen, please put your hands together as this award goes to Gujarat Power Research and Development Cell. And let's welcome Mr. Jignesh Puri Sagar to receive the award. Come on, everyone. Let's make a big round of applause for the entire team of Gujarat Power Research and Development Cell. Congratulations. Mr. Dinesh, would you like to say something? How do you feel after receiving the award, and how has your experience been here at EPS EXPO 25?
It has been quite a good experience. Many new and innovative products have been found here, and we being an R&D entity, we always strive to do some new R&D in the field of power utilities for the better tomorrow and greener tomorrow. Thank you.
Thank you so much. Thank you, sir. So the next category that we have is the Renewable Energy Leadership Award. This award celebrates visionary leadership and pioneering contributions in advancing solar energy, driving innovation and shaping the future of the renewable power sector. And to present this award, I would like to invite Mr. Manoj Kumar Singh, founder and CEO, Net Zero Think Private Limited. Ladies and gentlemen, please put your hands together as the Renewable Energy Leadership Award goes to Internet Infra Engineering Private Limited. Let's give them a big round of applause. Everyone, come on. Congratulations to Internet Infra Engineering Private Limited. So, I request you to say something to the audience. How do you feel after receiving the award, and how has your experience been here?
Thank you so much.
That's all? All right, thank you. Now, the next category that we have is the Renewable Energy Leadership Award, where we are recognizing the exemplary leadership, vision, and commitment in driving innovation and growth in the renewable energy sector. And the award goes to Power Track Group. Ladies and gentlemen, please put your hands together for the Power Track Group. And I would like to invite Mr. Deepak Lodhe, Director, to receive the award. So would you like to say something?
Hello. Yeah, so I would like to thank EPS team. This is the second edition. and we really enjoyed over here. And yes, we are looking forward for the next exhibition with EPS. Thank you to everyone.
Let's take a big round of applause, everyone. Come on. Thank you so much. And thank you so much, sir, for helping us to the award ceremony. Now, the next category that we have is the Outstanding Industry Contributions Award, where we are honoring whose innovations, leadership, and initiatives have significantly advanced the electrical power and solar industry and driven sustainable growth. And to present the award, I would like to invite Dr. Anand Kumar, Joint Director of CPRI. Can we make a round of applause, ladies and gentlemen? Come on. So the Outstanding Industry Contributions Award goes to Proc Devices Private Limited. Let's give them a big hand. Do we have anybody from Proc Devices Private Limited? All right, so moving on to the next category, it is the Lifetime Achievement in Energy Sector, where we are honoring the outstanding vision, leadership, and lifelong contributions that have shaped and advanced the energy sector. And the award goes to Electrical Research and Development Association, ERDA. Ladies and gentlemen, please put your hands together. Come on. Mr. Shailesh Modi and Mr. Pranav Parekh is coming to receive the award. And I request, sir, can we take a moment? I want to invite Mr. Hari Bala Subramaniam, Business Development Director, Janitsa Electronic GmbH, to help us through the award. Ladies and gentlemen, please put your hands together for Electrical Research and Development Association as they are awarded with the Lifetime Achievement in Energy Sector. Congratulations. Mr. Shailesh and Mr. Pranav, would you like to say something and put light on how has your experience been here and how do you feel after receiving the award?
Good afternoon. Thank you, EPS EXPO, for this wonderful exhibition. An amazing initiative in the state of Gujarat, which is actually leading the renewable path. And think about the award, it's a lifetime achievement award, but it's just the beginning of ERDA. We have recently completed 50 years, and we have many more years comes.
Thank you so much and congratulations. So would you like to say something?
Thank you very much for EPS team for awards as a token of appreciation. I'm sure these awards will encourage us for doing better, and I'm sure our ERDA team will do better and better for future for industries, utilities, and coordination. Thank you.
Thank you so much. So, ladies and gentlemen, can we make a big round of applause for all the winners and achievers? A more louder, please. Come on. Let's keep the energy high. Come on. Thank you so much. Well, as we come to the end of the EPS EXPO 2025, I want to extend my heartfelt gratitude to everyone who have made this event possible. To all our exhibitors, to all our visitors, to all our partners and sponsors who have made this day possible. As we conclude the award ceremony, we have honored the outstanding achievements and contributions of individuals and organizations in our industry. Let's carry forward the spirit of innovation, collaboration, and excellence that we have ever seen. To our sponsors, partners, speakers, and attendees, thank you so much for being a part of EPS Expo 2025. Your involvement has made the EPS Expo a big success, a memorable and impactful event. Thank you so much, ladies and gentlemen, once again, and we will surely see you next time. Thank you.
એ પિક્ચર ના જોયું તો દુનિયામાં રહેવાનું નથી જોયું. એ પિક્ચર જોવા જેવું છે. જે એનું છે એકદમ તેરી પસંદ નહીં ખરેખર જોઈ મવાલી હોય એના ઉપર આમ પૈસા કરોડ પછી કેવો આમ સારું ચંદન તરીકે ના વાળું ચશ્મા વાળી છોકરી હોય લંડન બન્યું ગુજરાત